Hello and welcome. In today's video, we are exploring a fundamental data structure, that is queues in Python. We will learn what a queue is, how it works, and why it is essential in coding interviews, exams, and real-world programming. Let's see what is a queue in Python. A queue is it is a linear data structure as we have seen in stack, but the queue follows the first in, first out principle, which is exactly opposite to stack FIFO principle. So queue is also a linear data structure. It follows FIFO principle that expands first in, first out. So for example, in supermarket, the first person in the queue is the first one served with the service from customer agents. So we have basic operations in queue as similar in stack, but we have different operations, which is enqueue, dequeue, peak, isEmpty, and size. We have operations for queue. Number 1, enqueue. Number 2, dequeue. So what is enqueue? Nothing but add element at the end. What is dequeue? Remove and return the first element. And the third operation, same as in stack, which is peak, but what it does, view the first element. In stack, we have peak that returns a last value, but here it is to view the first element, but it doesn't remove. Fourth one is empty. So it checks whether the queue is having elements or not having elements. And then fifth operation, size, which is count of elements in the queue at that particular moment. So these are all the 5 basic operations for queue. In examples, we will see in detail how we be programming on these operations based on lists and linked lists also. One important point is on queues to remember. Queues power many real world tasks like job scheduling for printers, for processing e-tickets, enabling BFS, breadth first search in graph algorithms, and many more. So now let's see using Python list as a queue. Let's see an example with a simple programmatic implementation of queue. So first of all, what we have to do, we have to define a queue as a list. This is queue as list. Let's take queue as a variable, that is list. Initially it is empty. So now enqueue, the element which is nothing but add at the end, on list, how do we add? Using append method. So we use queue dot append and say Anna is a person name we are adding to the queue. Again append, then at the end using append method of list. Likewise, we can add n number of values to the queue at the end. For now, let's take 3 values in the list. So let's now see what the queue holds. So queue, so this prints all the values that we have appended in the order as a list Anna, Ben and Casey. So now in queues, the first element is often referred as front. So let's take front as a variable name equal to first variable, first value, which is queue of 0, and this front is utilized as peak. So if I want to fetch peak, which is nothing but front first element, as it is first in first serve, we are fetching and viewing first element using peak. And the other operation we have is dequeue. So this is nothing but fetching the first element. So what we have to do, we have to fetch or remove the first element, which can be done using list pop method by mentioning the index value of first element in the list. So we have to do popped element equal to queue dot pop. We mentioned index 0, so it will pop the first element. So now we have the first element removed and is assigned to popped. Let's print which element has popped with the operation popped. So this will remove the first element and we are assigning into popped. So it will print the popped after removing from the queue, which is nothing but dequeuing. Next operation is empty. Before that, we will see what are all the elements in the queue present after dequeue. We just pop, that is nothing but dequeued. So let's print and see what are the values in the queue. So here we have popped, removed the first element Anna. So this print statement has to do only the remaining values, which is Ben and Cassie. So after that we will see is empty. Print, we can directly do is empty. We can print for particularly for queues, not bool of queue. So this one, what it does, bool of queue will return. If queue doesn't have elements, it will return false, and not false becomes true. So is empty becomes true. If queue has elements, bool is true, bool of queue is true, and not bool is false. So is empty becomes false. You can try at the terminal by printing this print statement. And the last and final operation, which is nothing but size of the queue. For list, it is length of queue that returns the number of elements present in queue, which is 2 after popping the first element. You can even add element again and see the length to find it is printing the number of values. So that's about all operations in a programmatic way. Now let's see one of the important interview questions on this discussed operations. One of them is, why is the most important question that is asked in interviews. This seems very basic, but these are all the important points to remember. The question is, why is pop of 0 on a Python list inefficient? Just we did by pop of 0 here when removing, but the interviewer might say, is this efficient method to pop 0? If it is, why? If it is not, why it is inefficient? So the simple answer is because it shifts all remaining elements one position forward, O of n time complexity. So that is the reason it is inefficient. So after removing first element, the second element will be shifted to first place and the third element will be shifted to second place. Likewise, the number of elements, if it has 3 elements, it will shift twice. If it has 1000, it shifts 999 times. So which is time complexity. This shifts which causes O of n time complexity. That makes pop of 0 inefficient. So if you say this is inefficient, the interviewer might ask, so after knowing this reason, what is the best way without using pop 0? So the better choice is using collections.deque. So let's see what is the efficient way. For efficient queue operations, use dequeue from the standard library instead of using normal list pop method. So let's see how do we do programmatically using collections.deque. So first what we have to do, we have to import dequeue from collections. Let's start importing from collections, import dequeue, and then we have to initialize queue with empty queue, which is done using queue equal to dequeue. It initializes the queue with empty, and now we have to append the values as same as in list before. Append Anna, append Ben, append Q dot append Cassie. So now how do we print these values? We have to do with a specific method available after initializing queue with dequeue. We have one method that is available, which is pop left, which what it does, it follows the FIFO method, first in first out. Let's see. how do we print the queue values? Dequeue queue dot pop left. So this will print one by one in first in first out method. So this is how we print when we do with dequeue. So now the major difference between append and pop left are O of 1 making dequeue ideal for queue logic. So this will just remove that time complexity as we had in pop. It will just print the element with time complexity O of n. So making dequeue ideal for queue implementation. Let's see one more question on Python operations. What is the time complexity of enqueue and dequeue in collections.deque? This is also one of the important question that you need to remember before going to any Python interviews on DSA. What is the time complexity of enqueue and dequeue in collections.deque? So what is it? Answer is both have O of 1 time complexity, which is a constant time complexity. So that is the enqueue and dequeue time complexity. That is constant time. That is what you need to mention. And one more sample we will see. Queue with a dequeue dot queue. Before we have seen dequeue from collections. Now we will see queue dot queue, which is thread safe. So for multi-threading apps like producer consumer systems, we use queue from queue, which is again like collections dequeue. Let's see how do we implement this. So we have to import queue from queue module, and let's define queue as queue, and queue dot put is the method we use for push, and queue dot put likewise queue dot put Cassie. So this is how we will be putting, which is nothing but adding values to the queue when we are using queue dot queue. Now the same ways we have get method, like we have put method, we have get method to retrieve the values from the queue. Let's use this in the print statement. Print dequeue queue dot get, which fetches all the elements that are put in the queue, and this will automatically fetches first in first out order, which is thread safe, especially when we are doing any concurrent job processing like concurrent environments. So we have to utilize queue for thread safe queue implementations. Let's see one interview question on queue.Queue. So the question is, how queue.Queue is different from collections.deque? So if you have observed, it is very clear that queue.Queue is thread safe, dequeue is faster but not having or not dealing with the thread safe at all in the programming. Okay, you just need to mention queue.Queue is thread safe, which doesn't exist with collections.deque, but it is very faster. So now let's see, we have built a simple program using list. We have appended, we have retrieved values using pop, and we have seen best effective methods using collections, dequeue and queue.Queue while fetching and while adding the values to the queue. Now let's create a queue clause and make each operation enqueue, dequeue, peek is empty as method to it. So let's add so let's take a sample class like before, a class queue with a init method, with a init method, which initializes the self.queue as empty list, and enqueue, which passes self and element. Enqueue is adding, so we will do with append self.queue.append the element passed. Likewise, dequeue return self.queue.pop0, if not self.is empty, else queue is empty. So this is how we do dequeue. And peek returns the same way, self.queue of 0, instead of doing pop-o, we are doing queue of 0 because we are just viewing the value, we are not removing the value upon a condition that if not self.a is empty, else queue is empty is the message shown on peek operation. And the next method operation is empty, which returns length of self.queue compared to 0. If 0, it returns true, that means is empty. If length is not 0, it returns false, which is not empty. And the last method operation on queues, which is size, just return length of the queue, which is self.queue. You can try calling this method. Before that, we have to create a queue using the class that just we have created. Then we can print, we can enqueue, dequeue, peek and check that if it is empty or if its size is being returned as length or not. That's all about implementation using class or queues. This is a basic implementation again as queue with list. So if you want to avoid costly shifts together, implement the queue using linked list, which is again similar to it, but what we will be doing like before in stacks, we will create two classes, one for node, one for the queue. So let me take a sample from the previous example, which we have modified for queue. The node class is same and the enqueue dequeue will differ, and the remaining methods are almost same. So this is the class that we have created as similar to the before stack implementation, and we have to add the class node prior to this, because we will be utilizing class node within the queue class. So class node and init method has data, self.data equal to data, and pointer self.next, which holds the address of next element, which is none, and class queue has init method which defines empty queue as empty list, and enqueue append element, and dequeue just it pops the 0th element if the self is not empty. Directly we are writing without the queue self dot is empty, otherwise we are returning queue is empty message. Likewise for seek as well, we will return self dot queue of O instead of removing it if it is not empty, or return a message it is empty. So return length of self dot queue equal to 0, which returns true if empty, returns false if it is not empty. And then last method, size length of queue, that returns the size of the queue. You can try executing these methods by calling the queue class methods. So that's all about implementation using linked list way for queues. If you have any questions, you can post in the comments. I'll be happy to help you. So you need to remember again, the dynamic version doesn't require shifting, wherein in list way the shifting is required, which increases the time complexity often. But in linked list, the dynamic shifting is not there, and it improves the performance. But one drawback, it uses extra memory per node because it holds the address of next node. And let's see one more question, interview question. What are the pros and cons of linked list based queues? So this is direct question, and we all know, just to reiterate for the interview purposes, the pros is dynamic size, and no shift. And cons of linked list based queues is extra memory for node pointers. and code slightly gets complex based on the problem and solution using linked list method. If you have to traverse, it is not like a simple while for loop, as in this, it becomes traversal through each and every element utilizing the pointer to next element. So the code complexity is the con of linked list based queues. As we already discussed before, let's go through to remember the real world application of queues. Number one is job scheduling. Like in general printers and any normal tasks. And BFS, which is breadth first search in graphs. And number three is message queues in distributed programming. And event handling like keyboard and mouse, etc. So we can expect an interview question on this as well, like name a popular graph traversal algorithm that uses queue. So we have many times mentioned that is nothing but BFS. Breadth first search uses queue to traverse nodes level by level. Let's discuss all the pointers that we have discussed about queues. Let's reiterate through one and all. First one is queue other to a principle called FIFO. Number two, list in Python, and then simple cases we use queues, and we have to prefer collections.deque for efficient single threaded operations. Use queue.Queue for thread safe concurrency multi-threading. Consider linked list implementation for dynamic memory needs, and consider queues for job scheduling, breadth first search, event handling. So that's it, all about queues in Python. If this video helped you prepare for your interviews or exams, like, subscribe and let me know in the comment section. See you in the next video. Thanks for watching.